Okay, well, my name is Sumeet Singh. But before I introduce myself, I want to introduce my colleague Francis Liu, because he pretty much has done most of the work. He leads HBase development at Yahoo. He's also a Hive contributor and used to be a PPMC member for HCatalog, so it's merged with Hive now, so it's pretty much an HCatalog committer, you can say. And he's used Hadoop at Yahoo for a while as well, but really took the challenge to platformize HBase at Yahoo, so which is what we're going to talk about. I manage the product management teams for cloud services and Hadoop at Yahoo. And when we were actually looking at the types of use cases HBase was throwing at us, well, let me put it this way, the customers were throwing at us. HBase just sounded like an excellent match for a lot of different things. And so my talk is mostly going to be about what are those lots of things, right? Why is it so important for us? Okay, so we should get started. But before we get deeper into kind of the talk itself, there are 5 broad topics we would like to cover here. Motivate multi-tenancy, right? Why did we need it? And then talk about the various use cases we see, at least from a consumer internet company standpoint. It's mind-boggling. It's just been a few months, and you can see how different people are intending to use HBase. Some are already using it, so we'll talk about those. We'll briefly touch upon how it works with other components in the Hadoop ecosystem, because we have a lot of other things in the platform. And then Francis will actually talk about how he accomplished multi-tenancy. Well, him and his team, some of his team members, I see Govind here sitting in the audience. And then finally, our experiences in deploying secure Hadoop. So we'll go a little bit deeper into security, which becomes a concern when you have a multi-tenant platform, particularly for sensitive data, right? And then we'll open it up for questions if you have any at the end. Cool. So I drew this chart a while ago, actually, in the beginning of the year for a blog post, but it tells a lot of different stories. And one of the stories I wanted to motivate here for multi-tenancy for HBase was the uptick we saw in the adoption of Hadoop platform at Yahoo, right? So it's one of the most widely used platform at Yahoo now. You can see some of the scale numbers here, over 360 petabytes of storage, over 40,000 nodes. It's pretty amazing. It's pretty immense. Every month, we have about 800 developers who come onto the platform to run their applications, write their jobs, and do different things with it. And the number of applications that run on this platform is also pretty mind-boggling, over 400. So what made it possible, in my opinion, is the breakout year that we saw around 2009, 2010. And you would see that right around that time, when we saw this uptick in adoption, we had introduced multi-tenancy, we had introduced security, and we had introduced partition namespace in Hadoop, right? So multi-tenancy sort of was the answer to that uptick or breakout, as we can call it, for the platform, and why it became so pervasive within Yahoo. We're sort of seeing the same thing with HBase, but HBase has a slightly different history at Yahoo, where we started off with some very large projects using HBase, and they had all the resources, investment dollars to actually run and operate their own clusters. When I talk Hadoop in the previous slide, that's the shared grid, that's the shared environment for all of Yahoo, so it's a common platform. HBase wasn't platformized the same way. So we had content personalization group used HBase in a pretty big way. And then the other project that used HBase in a big way was web crawl cache, and really immense installs. I mean, I think WCC at that time was the largest HBase install anywhere in the world. It was almost 700 to running to 900 nodes. The way you count it, 2 petabytes of data stored just in HBase. And then what happened was, in 2011, we kind of put HBase as a sandbox in our environment, in the public environment, as people call it, versus a private environment, the shared grid. But we had not platformized HBase. What it means is that we didn't make HBase ready for everybody to use. And there were concerns around how we're going to operate many clusters. We already had many when it came to Hadoop. Other kinds of things like isolation, security, all of them were a concern. So, thankfully, somewhere towards the end of 2012, Francis took up the challenge and kind of got it ready in pretty much maybe a quarter. At least got it started. So we have some more key sort of customers at Yahoo now running on the multi-tenant platform. And as you would see, the types of use cases we're seeing now has just exploded. And we think that multi-tenancy is sort of the reason why we're seeing that uptick. A lot of people wanted to use HBase but couldn't because they were restricted. They didn't want to operate a private cluster, wanted us to host it, and for us to host it, multi-tenancy was sort of the key feature. So a lot of this talk is about how sort of multi-tenancy creates that, what I would call as breakout type adoption for platforms. And in this case, it's the Hadoop platform where HBase sort of became a primary citizen. Okay, so we're also in the process of moving those private clusters now onto the shared environment. So they're all going to move. These are very preliminary estimates, probably on the conservative side of what we might see by the end of the year. So by the end of 2013, might have about 4 or 5 petabytes of data stored in HBase, roughly between 2,500 to 3,000 servers. And these are high-end servers. These are newer ones, right? So, okay. And then again, as we kind of went through the discussions with our customers as to why they wanted HBase, we came up with a host of things. And as you classified that, what we observed was that pretty much all of Yahoo's business wants to run on HBase, or at least have HBase something to do with their business. So be it ads. I mean, we have 4 or 5 sort of mainstreams: ads, media, search. What else? Mobile. It doesn't matter what the business is. It is trying to use HBase in a very interesting way. So if you look at search, they're obviously big. One of the large projects there is about storing the entire map of the World Wide Web, right? It's pretty immense. Then we have cases around analyzing queries, search queries. So these queries make keys that are very interesting from a monetization standpoint. We really want to understand what people are searching for. And there are billions and billions of these keys that you could search on using HBase. Local listing also is trying to use HBase. We are something we call as incremental disambiguation. And the problem here is that local listings and the quality of those listings are so bad that, it's hard to sort of deduplicate some of them, because what might happen is that duplicate listings will show up. So there is a way that they want to use HBase to accomplish that deduplication or disambiguation, so that the end result that consumers see is a clean list. Analytics is a lot around, again, these search key terms and stuff that they want to report against using Hive and HBase. So again, as you see, search itself is a very rich breeding ground for using HBase. Communications platform is yet another interesting area. And the types of things we're seeing there is around anti-spam or anti-fraud, whatever you want to call it, compromised accounts, detecting those using HBase. And I'll talk about that in a bit of detail. So I'll do a deep dive on a few of these. Can't obviously talk about all of them. Log analytics, again, mail is the single largest infrastructure at Yahoo, pretty immense, way more than what you saw for Hadoop. So they want to actually understand everything that goes on with their server using HBase. So essentially doing some type of real-time monitoring behind the scenes using HBase in terms of exactly what happens with their infrastructure. For example, if a server has spikes, they want to understand why it's spiking and do something about it quickly. Metadata management is yet another sort of project. I have kept it outside the realm of our scope of things because they do things differently, but essentially think of it as you're using HBase to store certain states about mails. Cloud platform, so our group internally kind of use HBase for a number of things. A lot of that is around performance monitoring, auditing, analytics, and other kinds of things. So we have OpenStack, a online monitoring platform that's trying to use it. Interesting, right? Monitoring is trying to use HBase for monitoring. So, and then performance platform, that's a platform where we actually offer performance as a service to our customers. And then consumer platforms also has a lot of interesting cases. So think of our content management systems that actually is built on Hadoop. Uses HBase in a very interesting way. So what they have is that each piece of content can be editorialized by a number of editors, right? So each piece of content sort of becomes the key, and then the facets these editors are editing becomes the columns. So multiple editors could be creating these facets in tandem. And you have HBase as sort of the source of truth for these objects, and yet it has a state which is truly reflective of what's going on. It also provides us the buffering space when you're thinking about streaming rights for content. So lots of interesting use cases just within that for HBase, just within content management. So I've shown it as a single bullet. Let me skip some of them, otherwise we're going to run out of time. Traffic protection is yet another interesting case. So there are cases then in advertising now, on the advertising section. And traffic protection, the way we see people use HBase is that if any one of you here is from the advertising background, you would understand the click impression frauds and things like that, right? Things that are very hard to detect for an ad server. It has to let those things come in. There are other types of attacks, bad things that happen that you could detect at the network level, stop it, like denial of service attacks and other things. There are financial frauds that you can't. So you let them in, but you don't commit the transaction. You keep it and figure out if it was bad, filter them out. Don't bill people for that, right? So they do that using HBase. Some of the other things here, ads data management is yet another important use for HBase where people are using, we have a common platform for all booking all advertising onto Yahoo. And what it does is that it creates these data that multiple applications that sit on top of that platform use. And previous to HBase, what people would do is that they would make copies of these data and put it on Hadoop Grid for further processing by their applications, right? So what you end up in a state where you have these multiple copies of data everywhere, and they're all inconsistent, and different applications are making different meanings out of that data. So there was no common sort of source of truth for that data. And HBase allowed them to actually put a shared set in one place, so everybody looks at a consistent set of objects that comes out of the app platform, the advertising platform, and then they use that data to build their applications. So again, very, very interesting ways people use it. Personalization, I'm going to talk a little bit about that in detail. Mobile, again, Flickr is doing some amazing things. If you haven't been to Flickr, you should, particularly on your mobile. So a lot of these types of businesses are also using HBase. So I'll move on. And then actually, I will deep dive into a little bit of a few of these use cases. But let me walk through why it's so appealing to us. I mean, we had a problem, and HBase sort of solved that problem. And the biggest problem we have had was that the user base for Hadoop was very large at Yahoo, right? You know, hundreds and thousands of people writing applications, processing their data on the platform. Yet they didn't have a solution for storing mutable data or doing random access. HDFS doesn't do that, right? So HBase kind of became the natural fit. It's part of the Hadoop ecosystem, and you know, people were very, very familiar with Hadoop at Yahoo. So that's probably one of the biggest reasons why it's attractive to us, right? So a very large developer base, and then HBase has integration with all other components we were using, right? Pig's very popular at Yahoo, Uzi is very popular at Yahoo, Hive's getting popular. So all of these components work seamlessly with HBase. We'll show some of that in this presentation. And then, of course, the community. I mean, you guys, it's just a phenomenal community, and we have full confidence that we're going to get support for things we need from HBase. You know, we have our own developers, but at the same time, they can only do so much, and that's the beauty of an open source community. In particular for HBase, it's a very active community, and you can see here throughout the day. HBase throughputs were very attractive to us, particularly when it comes to write rates. It supports tens of thousands of writes per second. So it supports our scale. The latencies are somewhat acceptable to us. And there was support for all kinds of other things that we needed, right? That people are customers, my customers. I'm the platform group. I serve rest of Yahoo. It pretty much had those things that people were looking for. So it was quite natural for us to introduce it or platformize it and make it ready for everybody else to use. So let's go slightly deeper into a few of these use cases, right? Personalization is huge for us. And the concept is very simple. I'm not going to be able to go in details here. But what you do is essentially you have these pages that people visit, and they are instrumented in a certain way to give you what content, what users are looking at. Right? So you gather the audience event via what we call as a data highway. It's nothing but a data collection mechanism. Dump it on Hadoop. Right? So all user activities end up in Hadoop. So these are essentially click streams. We have a content management system, as I said, built on top of Hadoop. Right, so it's serving both the properties, and it also has a copy onto the grid for doing many interesting things, content enrichment, content sharing, all kinds of applications. So you have content, you have user activity on Hadoop, right? And then what HBase does is that it allows us to crank up models, both for user activity against a particular piece of content and the information about the content itself. So you bring the two together. And you serve that. We have a host of cloud serving systems, AdStack. The team that worked on personalization had its serving layer. So all that serving layer eventually ends up matching the content that a particular user is interested in based on the learning they have derived in the past from the user activity. Right? So you're serving pieces of content to the user that the user is interested in by doing this. And HBase, as you see, plays a pretty critical role there. So that's what personalization is, or content personalization. And what we've done now is that we've shortened the feedback loop. But interesting thing is that we introduced yet another set of technology around stream processing, which is Storm, on our platform. But you see, HBase still is in play in a very interesting way. So you have both the long-term sort of pipelines and the short-term pipelines for modeling user activity and behavior pretty much in the same common store. Right, so the HBase as a technology sort of still plays. Although we are revamping our personalization efforts, HBase still sort of stays front and center of our personalization story. Okay, and what you end up with this beautiful sort of web page. This is our new homepage if you haven't seen it. NBA finals are going on. I'm a big basketball fan, rightly so. It actually showed me a basketball page when I was logged in. So there are these 2 or 3 different modules here. One is the activity stream. The first ones we call as the today module. And then, of course, the ad stream. Okay, so HBase is critical for personalization. Web crawl cache is yet another use case. And I'll try to be quick. Polar basically understands when it needs to go fetch data. Fetcher fetches that data, block of data, puts it into HDFS. Ingester breaks it into block-loadable HBase files, merges it with the existing HBase tables, and eventually what ends up happening is that you have the entire World Wide Web in HBase. And then you can do lots of downstream and interesting things with that data, right? Billions and billions of documents. Okay. There's some pretty amazing scale numbers if you're interested. Over 85 terabytes of data come every day. That whole thing will end up being like 4 or 5 petabyte itself, just for a few days. It's not retained for too long. We talked about mail. Hadoop plays a huge role in actually filtering out spam mails, and there's filtering like 20 billion spam mails every day. But HBase has an interesting use here, where a lot of people actually get hold of someone else's account. Right? So you won't be able to figure out whether it's genuine spam or not until for a few days. And we don't want to. We don't want to alert the spammer right away because they'll find new mechanisms to break things. So what we do is actually we have these events sequenced in HBase, and we run detection algorithms to figure out, or classifiers as we call it, to figure out which accounts are the compromised accounts. And if it's not a compromised account, we declare it good. If it's a compromised account, we either throw him a challenge or deactivate his account, right? To keep the bad guys out. And throughout these use cases, you would see some common patterns emerge. The first pattern is quite simple. It's used as a key value store, classical NoSQL store with reads and writes. The second pattern, as you could see through all of these use cases, is about metrics or analytics, where you bring counts from various different sources, ingest them in HBase, and there's a query server. So there are some talks here about OpenTSDBs. It's kind of based off of this architecture. And you basically run your metrics or analytics type use cases using this pattern, right? The third pattern that we see is where HBase gets used as a store for type 2 dimension data. And a good way to think about this is, let's say you have an ad campaign running, and that information's in HBase. You have click stream of, let's say, a month worth, 6 months worth in Hadoop, and you want to do point lookups in HBase against those click streams, just to say figure out how much money did this campaign make at that point in time. Those are the types of things HBase gets used for. So you could use MapReduce, Pig, and other things to do those point lookups in HBase. And then this is the personalization use case or pattern I talked about. Content is also seeing this pattern. A bunch of other things are seeing this pattern, either just the top of it or the bottom of it. And this is more of this incremental processing type use cases where you store intermediate results in HBase, and HBase also becomes the source of truth for different types of data. And finally, we did talk about integration with other components. So it integrates very well with MapReduce, right? You have table input-output format that can read and write data using MapReduce and HBase. Pig also, as long as you understand this table schema, you can form tuples to do different things, which is read and write. It has to be an existing table, and you need to know the schema. And then HBase storage handler. Hive has probably the cleanest integration, in my sense, with HBase, where you could both create, drop, or read-write information into HBase. And we had, as I said, Uzi is very popular at Yahoo, so we added support for making Uzi work with HBase as well. And the idea there is to declare an HBase credential, and then when you execute actions in your XML, it kind of understands that that's an HBase type, that it needs to talk to HBase, right? So with that, that kind of at least gives you the idea why we had so much interest in platformizing it. And multi-tenancy was sort of the first tenet in making this possible. So with that, I'm going to invite my colleague, Francis Liu, to talk about how he accomplished it.
So before I start talking about multi-tenant HBase, let's just quickly look at Hadoop at Yahoo. So Hadoop at Yahoo is also multi-tenant, as Sumeet mentioned. And so we do this through basically three things, right? So you have security, which guarantees your privacy and your data integrity, integrity. And then you have job queues through the capacity scheduler, which guarantees you your compute resources. And then finally, you have HDFS quotas, which guarantees you your storage capacity. And so comparing that to HBase, if you wanted to do multi-tenancy, we basically need also security for your data integrity as well as privacy. And then we have three other things here to guarantee the resources you need. So basically, as Sumeet mentioned, we have a very diverse set of use cases, which means that we have a very diverse set of different workloads, which would require, again, resources across a number of dimensions. So that would be I/O, memory, disk. So we tried to sort of give users meet users' requirements on this based on these three things. So that's isolated deployment, which is a deployment approach. And then we have two new features we've added into HBase, region server groups and namespaces. Both of these features we've implemented internally, and we're working with the community to actually have it available to you guys. So let's just quickly walk through security so all of you guys know. The security model in HBase adopts the Hadoop security model. So there's basically two ways of accessing, authenticating with HBase. One is through Kerberos, And then, so that's normally used by users or daemons or long-running processes. And the other is delegation tokens. And these are normally used by computation processes such as MapReduce or any other framework that you might want to run on Yarn. And then HBase has its own set of authorizations. So you can basically grant privileges, read, write, create, admin. And then you can grant this on either a user or a Unix group. And this can be applied to either a table, a column family, or a column level. And one thing to note here is that only a global admin can actually create or drop tables. That means that in order for someone to create a table, you have to make it a global admin, which is unacceptable in a multi-tenant environment. So that's just one thing to note. Just a quick digression of security at Yahoo. So when we looked at HBase for security at Yahoo, it was more of to prevent misuse as opposed to preventing malicious use, because Yahoo, even though it's multi-tenant, it's still one company, so we're sort of still running in a trusted environment. And apart from preventing misuse, we want to provide privacy and some auditing. So it's been deployed in production for the last 8 months. So far, no major issues. I'd like to thank, I guess, Gary, one of the major contributors for security, who contributed it. We didn't have any major issues, but we did have some issues. So let me just walk you through it, some of it. So this sort of is a laundry list of things that we experienced. So when we first looked at security in HBase, there were actually a number of unprotected APIs, meaning that any user could just call these APIs and have HBase act on it. So for example, someone could just tell the region server to stop and die, or tell the region server to close, or to bulk load data. And then through the web UI, you could just actually decide to compact and split anyone's tables. And another thing is that there are some APIs that need to be authorized, client authorized, meaning that if I'm a region server, there's an API in the master that says, I'm registering as a region server. So in this case, there is no authorization available, so I could just say, I'm a region server, I'm registered with you. So though there's a workaround to this, you can actually set it as a policy in Hadoop to say that this API is restricted to this user. One thing to note that is that the Hadoop does have support for client authentication. Okay, and finally, HBase has both REST and Thrift interfaces, but neither of these actually have authentication. So what happens is that all these services run as a single user, and all the requests that's coming in is actually sent as that single user, which is unacceptable in a multi-tenant environment because you have multiple users actually sending out requests. So apart from that, we also had a few bugs while running in production. Well, not production, actually, in Sandbox. So one is the stop master or shutdown. So the interesting thing here is that there's actually authentication, authorization happening. So when you call shutdown, it throws the appropriate exception, but for some reason, this exception gets swallowed. And so it actually so the request actually continues and the entire cluster just shuts down. So we actually had one curious user call this API early on, and thank goodness it was in Sandbox. So if you guys are running security, please don't do that. And then the next one is Kerberos replay. So basically what happens here is that the gist of it is that when you make multiple connections across to multiple servers, Kerberos will see this at the same time. Kerberos will see this as sort of an attack and will deny you some of those requests. And this is especially especially bad when, well, not especially bad, but sort of not nice when, let's say, you're running HBaseCon, which normally connects to all your region servers to see what's going on, and then some of them fail, so it sort of prevents you from actually fixing whatever you're trying to fix, and you'd have to rerun it until you actually get a successful connection. So most of these issues we've either fixed internally and fixed outside, or we're pushing outside back to the community. So the other ones are mainly to do with integration with the upstream applications that use it. So some of them have trouble, are dealing with delegation tokens incorrectly. Proxy users is something that Uzi needs to impersonate a user to actually submit the job as that user. So these things we've dealt with. So there you have security in a multi-tenant environment. So we have that. Now is deployment. So how do we deal with guaranteeing users the resources? One thing we've decided to do is, if you notice, is that we actually have two clusters. So we have an HBase cluster which has its own dedicated HDFS instance, and we have a compute cluster with its own HDFS instance as well. So the way it works is that essentially a user will launch a job, and then the job will actually run in this cluster and access HBase. The reason we went with this deployment is that we didn't want user processes and the HBase process contending for resources. And what's worse is that this user process might actually not be even related to that region server, or even related to HBase. So which would make it, which would be unappealing, as well as make it hard to actually tune HBase properly. So so here we basically guaranteed resource isolation for HBase. So now let's look at actually guaranteeing isolation at a lower granularity. So as everyone probably knows, so HBase serves out regions, but those regions don't need to be coming from the same table. It could be coming from different tables, and what's more, these tables might be from different tenants. So what does that mean? That means that if some tenant actually sends so many requests for one region that contains other regions, that means that it would be eating up all the resources. So you would be starving the other regions in that sense. It's the same thing to do with memory. You might be kicking out valuable cache space for another region. So the way we did it is that we basically had the way of defining a subset of region servers as a group and designate that these tables can only be served by these set of region servers. That way we guarantee that the region servers will only be serving regions from specific tables, or in that sense also specific tenants. So this basically provides you resource isolation at the region server level. And what's more is that we can actually configure each group separately based on what their workload is, which is something you'd want to do in a multi-tenant environment. So now we have resource isolation for I/O, for memory, for disk, right? And then so let's take that. So these are the APIs, essentially, just to give you an idea. These are the APIs for region server groups. So you can add a group, you can remove a group, you can essentially move servers between groups. So essentially assigning those regions and moving it to a group. And then you can move tables between groups. And then you can also balance just that group. And then something that's useful is as you create the table, you can actually specify which group it will end up to so that you don't have to move it after creating it. And again, one thing to note is that you'd have to be an admin to actually do any of these APIs, even the create part. So here is essentially how it's implemented. So all the blue stuff is what we've done. So essentially, we used coprocessors, which you'll probably see a lot in today's HBaseCon. So we have one coprocessor which feeds out all the APIs. You just saw this is the group admin endpoint. And then we have the group master observer, which captures the create statement and does the auto-assignment. So the heart of this piece is essentially the group-based load balancer. So the way HBase does region assignment is through what's called a balancer. And the way that works is that you essentially give the balancer a set of regions, a set of servers, and the balancer will spit out a map of region servers to regions, and then the master assigns it this way. So what we did was that we created our own custom balancer, which is the group-based load balancer, and it's actually not balancing anything. So what it does is it actually just groups the regions and the region servers by their designated groups, and feeds this one group at a time to the balancer, to the actual balancer. So this sort of guarantees you that the balancer only balances regions within a set of region server group. Okay, so 5 minutes. Okay, I'll go faster. So essentially, now you have all your you essentially have your resources guaranteed. So let's take this a step further. We've added namespaces. So what namespaces is, it's analogous to databases, right? So essentially, it's a logical grouping of databases, of tables, sorry. And so we essentially have this notation where your table is actually, the dot now has a special meaning in your table. It's based, the dot will designate the namespace and then the table. And so we've created also two reserved namespaces, the default, which is analogous to the Java default package, wherein if you don't have a dot, it will just go into the default namespace. And then we have a system namespace, which is where the meta table, the ACL table, all these other system-related tables will go into, and we will treat them sort of in a special way. So one thing we will guarantee is that all the system tables will actually be assigned prior to the user tables are assigned. We can add more things later on, but that's essentially what it does now. Another thing we're changing is with the namespace is that we're making the path on HDFS hierarchical. So that way you can actually set an HDFS quota on a namespace, so, which is very important for multi-tenancy. So this basically guarantees you your storage capacity. So tying all this together, another thing that namespace gives you is this intermediate level between the global HBase, right, and tables. And so you can basically have groups aware of namespaces and ACLs or security aware of namespaces. And what that gives you is that you can say, okay, this namespace has a default region server group. So when I actually create the table, it will actually, in this namespace, it will actually end up in this region server group. And then you can also say, okay, now I'm going to set write privileges on this namespace to this user. That would mean that now this user can actually create and drop tables within that namespace. And so now you see like the namespace becomes something per tenant, per user. They have more flexibility, and sort of they have their own sort of mini HBase cluster in a way, right? So another thing we've added is that apart from the other shared resources that we have, we also share the master and the meta table. And so we want to sort of limit the usage of that. And so we actually added quotas also. So right now we only have quotas for the max tables and the max regions that you have, which is sort of trying to prevent you from overusing the meta and the master. So this is the implementation. Essentially, the blue stuff again is what we've added. So essentially, you have the namespace stuff in core HBase. You have the table namespace manager, which essentially is this helper class to sort of write the namespace information in an HBase table. And then you have the table also mirrored in Zookeeper as a way of distributing all this quota information and namespace information to the region server so that it's actually enforced by the namespace controller, which is running on all the master and the region servers, which is both a master call processor and a region server observer. So in conclusion, you can say that we've achieved multi-tenancy through security. We've achieved isolation through the isolated deployment as well as region server groups. And we've sort of given sort of a workspace or a resource allocation to tenants via a namespace. So, okay, so I think that concludes our talk. Any questions?